Hello, algebra students. We are working in Unit 3, and today we are talking about slope. So our goal today is that we will be able to find the slope of a line on a graph, that we will be able to find the slope of a line given 2 points, and that we will be able to find the slope from a written situation. So first of all, let's talk about slope. You've probably all heard about ski slopes, etc. So slope is really, when we're graphing linear functions or lines, it is discussed. Slope is always brought up. Slope is an identifying characteristic in linear functions. So when we look at the two graphs below, both have a line graphed. And think about what are some similarities and differences that we see between the two lines. So first of all, if you look at both of those lines, as you read them from left to right, the same way that you would read a sentence, the lines are increasing. Okay, so let's go ahead and write that down. As we read the lines from left to right, that both lines are increasing. And in algebra, that is how we read lines. We always read our lines from left to right, the same way that you would read a sentence. So as we graph the lines from left to right, both lines are increasing. Okay. The first line is rising, so that's a similarity. Here's a difference. If you look at the first line, it's increasing at a faster rate than the second line, so that's a difference. I'll just put S for similarity here, D for difference. The first line is increasing more rapidly than the second line. And the definition of slope is the relative change in y versus the relative change in x. That's written as a ratio. So remember, a ratio can be written as a fraction. And we will go ahead and write that as change in y over change in x. So delta y over delta x. So you probably heard of Delta, the airline. Delta is actually the fourth letter in the Greek alphabet. And delta in math and science is used to represent change. So anytime you see the triangle, that is representing change. So the slope formula is the change in y over the change in x. So delta is a great name for an airline because it helps you change your location from one point to another point. So that's just an ideal name for an airline. Okay, delta. So when we're looking at slope formula, change in y over change in x, delta y over delta x, we're going to be talking about two different points. When we look at our first point, just to differentiate between the 2 points, we'll call the first point x sub 1, comma y sub 1, and we'll call the second point x sub 2 and y sub 2. Okay, so these are subscript numbers. So we say x sub 1, y sub 1, x sub 2, y sub 2. So the slope formula, if we're looking at the change, delta, which is the difference, we know mathematically difference is another word for the answer to a subtraction problem. So when we have delta y, we're looking at the difference between two y values. So y sub 2 minus y sub 1. And the change in x is the difference between our x values. So x sub 2 minus x sub 1. Okay, so that's slope. We always use a lowercase m to represent slope. So m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That is the slope formula. All right, when I'm graphing lines, I like to use a protractor when I'm just using regular paper and these smaller sized graphs because it tends to fit on the paper a little bit nicer. It also stores nicer in a folder than a full-size ruler. So I kind of, for most of what we will be graphing this year, either a half-size ruler, so this is a 12-inch ruler, half-size ruler, or a little smaller is great. This is 6 inches, this protractor. But any straight edge, I mean, even really just using the edge of a folder will work for graphing, or a nice sturdy piece of small piece of cardboard. All right, so then let's go ahead to page 2, graphing lines given the slope and a point. So our slope is -2 and going through the point -2, 4. So the point -2, 4, we need a starting point, okay? It's literally the starting point. So -2, 4, we will go left 2 and up 4, and that's our starting point. So go ahead and plot that point. Now slope is always, we talked about slope being a ratio in the very first page, so change in y over change in x. So if you look at your y-axis, your rise is your y-axis. So here is the y-axis. It goes up and down. When you look at the x-axis is left and right. Okay, so when we talk about slope, we will frequently refer to it as rise over run. So how fast is it going up as a ratio to how far is it going over. So is the line really steep or is it more gradual? So we'll also call slope, if you go back one page just for a moment, we will also refer to slope as rise over run. So right at the bottom there, slope is a ratio of rise, which is our change in y, over run, which is our change in x, okay? Rise over run. And that's just a measure of how steep the line is, the ratio of the rise over run. So given that starting point of -2, +4, and we know that our slope is negative, our slope is -2, so when we read a line, the same way that we read a sentence from left to right, as we read the line from left to right, if it's increasing, so going up as we move from left to right, that has a positive slope. And if when we read a line going from, and it still has arrows on both sides, it's still a line, but as we read the line from left to right, if it's decreasing or the y values are going down, that has a negative slope. Okay, so when we have a line that has a negative slope, okay, and it's -2, this tells us our slope is, if I wanted to write -2 as a ratio, I would write it as -2 over 1. So this is my rise, or fall if it's negative, over run. So -2 over 1 is the ratio of the steepness, the level of the grade of the line. So -2 over 1, this is my rise, or you can refer to it as a fall, but really we just call it a rise. It's just a negative rise over run. So from my starting point, -2, 4, I will go down 2 and write 1. Down 2, write 1, down 2, write 1, and continue that pattern. Yes, of course, you could go down 4 and write 2, just keep that same ratio. And then we graph our line. And just as far as precision for hitting the points, it is a little tip for you. If you put your pencil on your point first and then bring your ruler to your pencil, then you're going to increase your chances of hitting all the points. Okay, little tip for you, a little graphing help. All right, let's look at number 2. Graph a line that has a slope of 3 and goes through the point 0, -4. So 0, -4 is our starting point. Remember, these are our points are always written in alphabetical order, X, Y, and then eventually when you start graphing things in 3-dimensional space like AutoCAD or things like that, you'll get a Z for the 3rd dimension. So right now we're working on a 2-dimensional graph, so we just have X and Y, and those are always in alphabetical order. So the first point is your X value, your second point is your Y value, your second number is your Y value. So 0, remember our x-axis runs left and right. So remember the first value always tells us whether we're going left or right. The second value tells us whether we're going up or down. So 0, -4 means we don't go left or right. We stay right on the y-axis. And the -4 tells us to go down 4. 1, 2, 3, 4. So that's our starting point. And then we have a slope of 3. So it's a +3. So we're going to, as we go from left to right, it'll be increasing. So m is equal to 3. And if you wanted to write it as a ratio of rise over run, you could write it as 3 over 1. You don't have to, but you can. So rise over run, I'll go up 3, write 1, up 3, write 1. and I'll be off the chart there at that point. So I'm going to go ahead and graph my line. Again, I prefer to put my pencil where I want my line to be, and then just bring the ruler right to the pencil. Our lines should extend to the edges of the graph, and they should have arrows to indicate that they're lines, not rays or line segments, okay? So we're not drawing a little piece of a line on our graph. We're going to go all the way to the edges of our graphs. Okay, number 3, graph a line that has a slope of 1/3 and goes through the point -3, -1. So the -3, -1, remember that's our x value, y value. That tells us to go left 3 and down 1. That's our starting point. And our slope is positive, so it's rising as we go left to right, 1/3. So I'll go up 1, right 3, up 1, right 3. And we always plot multiple points because that helps us to kind of have built-in check to make sure we're not mislabeling any of our lines or miscounting. Okay, so 3 points minimum when we're plotting a line, when we're graphing a line, excuse me. Okay, and again, extend your line to the edges of the graph, and we always put arrows to indicate that it is a line. Okay, number 4, write the equation of a line, or graph the line that goes through -4, 3 and has a slope of -1. So -4, 3 tells us to go left 4 and up 3. Plot our starting point, and this has a slope of -1. So I can go down 1, right 1 to get that -1 slope. And then I just went down 3, right 3 to kind of speed that up a little bit. So put your pencil on one of your points and graph that line. And if you're off just a little bit, that's okay. We do want to be neat with our lines. All right, so slope in terms of steep and shallow. So lines increase at varying rates. So the grade of a line, how rapidly or gradually it increases or decreases, just kind of tells us the degree, right? If you've ever been skiing, if you think of green hills, you know, Mrs. Collins skis on the green hills. I like the easy ski slopes. Okay, my kids are skiing on the blacks with obstacles, so black diamonds or double black diamonds. So they like those really steep slopes, and I like the more gradual slopes. So we have steep, absolute value of the slope is large. Okay, and then shallow, the absolute value of the slope is small. So absolute value is what we're looking at because we're not talking about whether it's a positive or negative slope, we're just talking about the degree of steepness. So that's why we're looking at the absolute value, not the sign, positive or negative. So again, shallow, the absolute value of a slope is small. Okay, probably a better way of saying that might be steep, it increases more rapidly, and a smaller slope increases more gradually. Okay, but these are good enough. All right, let's head on to the next page. Calculate and interpret the average rate of change of a function presented symbolically or as a table over a specified interval. Estimate the rate of change from a graph. So in these examples, determine what the slope is for each graph. Pick 2 points and use the equation for slope formula. So let's go ahead and do that. We'll make a reference triangle for these because we have the graph and it's so easy to use that visual. So I want to make that connection between the graph and the formula. So when I look at number 1, so none of the points are selected for us. So we want to look at that line and determine which 2 points we want to use to have to calculate our slope of the line. So as I'm looking through my line, I see here is a point that it exactly goes through. So I'm going to make that point stand out by making it a little larger. And then here's another point that our line goes through. And so I'm just going to make a reference triangle. So this is a triangle that I chose those 2 points. I'm going to make the reference triangle to help visually show the rise over run. So I'm just going to go down from this point and over from this point. And it doesn't matter whether you make your reference triangle above the line. I missed the point there. It doesn't matter if you make that reference triangle above or below the line. Okay. And then, so if I want to count this, the rise and calculate the rise and calculate the run, remember if this is our starting point, and so I count that as 0, and then I count 1, 2, 3. This had a rise of 3 units, and this is a starting point. So think of it like a number line, and this has a run of 1. Okay, so let's be careful that we always, when we're looking at a reference triangle to get our slope, we want to make sure that we are remembering to observe whether it's an increasing slope or decreasing slope, so positive or negative. As I read this line, and it does have arrows on it, they're just really tiny. Okay, they're super hard to see, but there are arrows on the lines. So as I read this line from left to right, it's increasing, so that means it has a positive slope. And it's always a ratio of rise over run, so 3 over 1. And I don't need to write the positive 3. You can if you want. I don't need to write the over 1. You can if you want. It would not be incorrect if you did that, but I just prefer to put the simpler answer sometimes. Okay, sometimes I'll put it as 3 over 1. You need to be comfortable recognizing it in either format. So let's look at number 2. Oh, actually, let's look at number 1 with the reference to the slope formula. So if I wanted to calculate the slope of the line, but I did not have a graph, or I didn't want to bother to make a graph of the line, I can also calculate the slope using the slope formula. So this, again, there was just a line. We chose the points. Okay, so this point was 1, 2. And this point is 0, -1. Okay, so we chose the points, and you can choose any points and your slope will still calculate correctly. Okay, so don't think that there are right and wrong points. You can calculate the slope from any points on the line. So then I can go ahead and do change in y over change in x. So remember that slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so it is completely arbitrary which point you want to call point 1 and which point you want to call point 2. So however, as a class, when we're going over problems together, let's go ahead and just make an agreement that when we read the graph from left to right, we'll call the first one that we come to point 1. So that's the 0, -1. And the second point that we come to as we read the graph from left to right, we'll call that one point 2. And again, it actually does not matter at all. It's just while we're learning the slope formula, sometimes kids get confused if I did the formula and called this one point 1 but they called that one point 2, then it just throws them off when they can't it keeps them from seeing what their actual problem and finding their real mistake. So if we just do it consistently, we'll call the first 1.1 and the second 1.2. That way we'll all have the same equations. But again, it's arbitrary and it will work either way. So y sub 2 minus y sub 1. So if I called this second point, or this point y sub 2, so these are my y values right here. I'll put a box around the y values. So y sub 2 minus y sub 1 will be 2 minus -1. So m is equal to 2 minus -1 over, and I have to go in that same corresponding order. I did this point minus that point for the y values. I have to go in that same order for the x values. This point minus that point. X sub 2 minus x sub 1. Okay, so this will be 1 minus 0. Okay, so then when I simplify those, m is equal to 2 minus negative 1. Remember, with integers, we can change that from a minus and negative to plus a positive. Okay, if you learned never subtract, add the opposite, I can change the minus to a plus as long as I change whatever sign is after it to its opposite. So I change the minus to a plus. I can do that as long as I take the number that's after it, the negative 1, I change it to its opposite, positive 1. So that will give us 3 over. And then our change in x, 1 minus 0 is 1. So I can get that slope graphically using my graph, or I can get my slope algebraically using the slope formula. Either way is acceptable. Now, since they gave us the graph, I'm going to go ahead and use the graph because it is quicker to draw that reference triangle and get the slope that way. The one benefit of doing this slope algebraically, a couple benefits of doing it algebraically. You don't have to make the graph, okay? And you don't have to worry about remembering whether it's positive or negative because algebraically it will work out, okay? But both methods are great. For the rest of these, we're going to go ahead and use the reference triangle because they already have the graph for us, and we'll be careful about remembering the positive or negative sign. So let's look at number 2. I'm going to just look at my graph. I just want to choose this point and this point. There are other points that you can choose and they will work equally as well. So then I'll make my reference triangle. I'm a righty, so I tend to make my my reference triangles under the line because I hold my ruler with my left hand and I can just see it better. So if you're a lefty, you might prefer to put your graph above the line or your reference triangle above the line, but it doesn't matter. So my rise, this is my starting point, so I don't count that, that's just 0. So my rise is 1 and my run is 1, 2. Okay, and then remember when we're doing the graphic, or using the graph to determine the slope, we have to remember to look for positive or negative slope. So as I read my graph from left to right, is it rising or falling, increasing or decreasing? It's decreasing. Okay, so that means it has a negative slope. So my slope is negative, rise over run, 1 over 2. Okay, and I don't know if we talked about this at the beginning of the year, but remember when we're looking at negative values, it doesn't matter where I put that negative. I can put it in the numerator. I can put it in the denominator, so 1 over negative 2, or I can put it in line with my fraction bar. It doesn't matter. Those are all the same number, okay? They're all negative half. They're all that number that's halfway between 0 and negative 1. So they're all exactly the same. So if you have I typically, I think, put mine kind of in line with the fraction bar, but it doesn't matter. A lot of people just always put it in the numerator. It's fine. They're all equivalent. Number 3, there are so many points. So I'm going to intentionally choose some that are far apart. I'll do this 2 different ways just so we can kind of become comfortable with this. If I do these 2 points here, right at the origin and just to the left of the origin, okay, our rise is 1, our run is 1. It is decreasing as we read from left to right. So our slope is negative because it's decreasing as we move left to right. And then 1 over 1, which will simplify to 1. So our slope is negative 1. If I had chosen different points, that would still work out correctly because it'll simplify down to negative 1. So let's go ahead and look at that. So perhaps I chose this point and this point. So I make a reference triangle here to there. Okay, so then I'll go ahead and measure these. So this is, again, the starting point. So that's 0. That doesn't count. 1, that's how far I went. 1, 2, 3, 4. So this has a rise of 4 and a run of, here's our starting point, 1, 2, 3, 4. So when I look at that rise of negative 4 over 4, when we simplify that, that simplifies out to negative 1. Okay, so again, it doesn't matter where you chose the points. It'll end up, like, even if you had like 6 over 3, it would simplify to 2. So you can choose different points than somebody else and you will both still get the same correct answer. Okay, so then let's take a look at number 4. Okay, so number 4, I'm just going to follow along my line and see whether there are any points that go directly through my line. And I do see 2. I see this one and here. So then I'll make my reference triangle. Oops, I have my protractor upside down. Okay, it would help if I didn't break the lead on the pencil, but there we go. All right, so then we'll look at our rise over run. So our rise is 1, 2, 3, and our run is 1, 2, 3, 4, 5, 6. Let me count that again. 1, 2. Oh, I think I miscounted here. So here's 1, 2, 3, 4, 5. Yeah, so that's 5. And so then our slope is positive because as I read the graph from left to right, it's rising. So our slope is 3/5. All right, so then we're going to look at the 2 special cases of slope. So number 5, we have a completely vertical line. Okay, so a lot of times students will want to say that has 0 slope. Not really. Okay, so let's talk about zero slope as opposed to a vertical slope. So this slope, this line, if we look at number 6, this actually has 0 slope. It's completely flat. When you're building a house or a floor, patio, things like that, you want to have 0 slope. You're intentional. You want it to be flat. Okay. Interestingly, not roads, and kids want to say roads, but roads actually have a little bit of a crown, and we do that on purpose because we want the water to drain off the road for safety. So little engineering tidbit for you. So when we have a line that's completely flat, it has 0 slope. So this slope is 0. It has 0 slope, okay? Or you can say no slope because it has no slope because it's totally flat. Mathematically, we prefer to say a numerical value on it, so we prefer to say 0 slope. So let's talk about that and let's prove it algebraically. Okay, it should make sense to you that has no slope, that it's flat. Okay, so let's talk about that and prove it algebraically. Let's choose any 2 points on the line. I'm going to choose 0, -2. And I'll choose any other point on the line. I'm just going to keep my numbers easy. I'm going to choose 2, -2. All right, and algebraically you can choose any other points on the line and it'll still work out correctly. So now let's use our slope formula. Remember, that's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we said we would agree to choose, as we read the line left to right, we'll call the first one point 1. So 0, -2 is our first point. And we'll call the second one our second one. So 2, -2 is our second point. Okay, so y sub 2 minus y sub 1 will actually be -2 minus -2. Okay, -2 minus -2. And then x sub 2 minus x sub 1 will be 2 minus 0. Okay, so let's go ahead and simplify with integers. Never subtract, add the opposite. So instead of minus -2, okay, instead of take away -2, we can add a +2. So never subtract, add the opposite. So in our numerator, what is -2 plus 2? 0. And in our denominator, 2 minus 0 is 0. What's 0 divided by 2? 0. So if you have $0 and you're sharing that between 2 people, you both get $0, okay? So 0 divided by 2, you can calculate that on your calculator as well. You'll see that it equals 0. Okay, over here, however, we're going to end up with the reciprocal type of relationship. We'll end up with a number divided by 0. Well, mathematically, we know we can't divide by 0. Okay, that's undefined. And so the slope of our line, that's going to be our answer to the slope of the line. Our slope is going to be undefined. Okay, there is no run. Okay, that's, remember, slope is rise over run. So if there is no run, the run is 0, I can't divide by 0. So my run will be 0. So that means I have undefined for my slope. Okay, think of skiing on this. You can't ski on that. It's undefined, right? You're not skiing, you're dying, you're falling off a mountain. Okay, so your slope is undefined here. Your slope is 0 here. This I can ski on, right? I just have to like walk on my skis. This I cannot ski on. That's called falling off a cliff. All right, so undefined. So let's prove that algebraically. So I'll choose any 2 points. I'm going to choose 3, 0, and I'll just choose 3, 3. Okay, we're not reading left to right because it's a completely vertical line, so I'm just going to call this point 1 and this point 2. So remember our slope formula. Is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So the y values. So these are our y values. Remember, it's x comma y, x comma y. Sometimes you might need to graph or to write those down every time to remind yourself. That's fine. They're alphabetical. So y sub 2 minus y sub 1 is going to be 3 minus 0 over x sub 2 minus x sub 1, 3 minus 3. 3 minus 0 is 3. 3 minus 3 is 0. And here we have that really impossible situation. We can't take $3 and give it to 0 people. So no matter what, I have that $3. I have that. It exists. I can't give it to 0 people. It's somewhere. Okay, so if you tried to do that on your calculator, even your calculator will tell you 3 divided by 0. Okay, divide by 0, error, or undefined. Okay, so our slope is undefined. All right, let's head on to the next page. All right, so now let's do some of those same problems, but we were not given the graph. So find the graph. To find the, here's our standard. Calculate and interpret the average rate of change of a function, presented symbolically or as a table over a specified interval. Estimate the rate of change from a graph. Okay, so we're doing this without a graph today. To find the slope of a line without a graph, use the slope formula. All problems will have 2 points given. So number 1, if we're just given 2 points, I think we don't have to even visualize them. We'll just call the first one the 1 and we'll call the second one 2. Okay, again, it's arbitrary. So this is x sub 1, y sub 1. This is x sub 2, y sub 2. If it helps you to label them as you're first learning the formulas, go ahead and do that if you wish. X sub 1, y sub 1, x sub 2, y sub 2. And remember our slope formula. Let's go ahead and write that. At the top, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's delta y over delta x. Okay, and then just so we have another way, it's also just simply referred to as rise over run. Okay, those are all again, represented with a lowercase m. Okay, so our change in y values. So it's going to be y sub 2 minus y sub 1. So negative 5 minus 5. You have to go in that same corresponding order for your x values. Negative 3 minus negative 2. Okay, never subtract, add the opposite. So negative 5 plus negative 5 is negative 10 over negative 3 minus negative 2. Never subtract, add the opposite. here I have 3 negatives, 2 positives. Which one do I have more of, negatives or positives? I have more negatives, so that answer is going to be negative. How many more negatives? 1, because the difference in the absolute values is 1. The difference between 3 and 2 is 1. Okay, negative divided by a negative is a positive, so we have positive 10. So our slope is positive 10. And then let's go ahead and look at number 2. We have 2, 5, and 1, negative 2. So I'm just, again, I'm going to call the first one x sub 1, y sub 1, x sub 2, y sub 2. Okay, so change in y, negative 2 minus 5 over change in x. Go in that same corresponding order, 1 minus 2. Okay, so in our numerator, never subtract, add the opposite. Negative 2 plus negative 5 is negative 7 over denominator 1 minus 2 is negative 1, and you can do the same thing there, never subtract, add the opposite. We had more negatives, so our answer is negative. How many more negatives? 1. So our slope is negative 7 over negative 1, which is 7. And then number 3. Okay, decide which one you're calling point 1 and which one you're calling point 2. So we have negative 13 minus 5. Okay, change in x, 5 minus 3. All right, so then equals, never subtract, add the opposite. So negative 13 plus negative 5 is negative 18 over 5 minus 3 is 2. So m equals, this simplifies to negative 9. Okay, number 4. Change in y, so it'll be 20 minus 11 over change in x, negative 3 minus negative 15. 20 minus 11 is 9. Never subtract, add the opposite. So we have negative 3 plus 15, so that's positive 12. So 9/12, those are both divisible by 3. So 9 divided by 3 is 3, 12 divided by 3 is 4. So our slope is 3/4. Number 5. Okay, change in y, negative 5 minus negative 5. Change in x, 9 minus 4. Okay, never subtract, add the opposite. So we're going to change the minus negative 5 to plus a positive 5. Negative 5 plus 5 is 0. And 9 minus 4 is 5. So we have 0 over 5. So that's just 0. Okay. And when you see, here's a nice little, when we start writing equations of lines later on, you'll see when your y values are the same. Okay, that's going to be really helpful when you're writing equations of the line. So when you see the y values are the same, that's going to help you to know the equation of the line is actually just y equals negative 5. So that's the equation of that line. Okay, so it's a little sneak peek ahead to Unit 4, writing equations of lines. Okay, and then when we look at number 6, we notice that same thing, but we're still going to prove it algebraically. So here's the equation of the line. So you notice how both of the x values are 6. If you were, again, we're not doing this till Unit 4, but when you need to write the equation of that line, the equation of the line, which again, we're not there yet, but it's going to be 6, x equals 6. Both x values equal 6. All of the x values will equal 6 because it's a straight line. All right, so let's go ahead and calculate the slope. If you're thinking ahead and you're thinking of our slope formula, I forgot the one there, x sub 2 minus x sub 1, you know you're going to have 6 minus 6. Okay, so you know you're going to have that divide by 0 case, so that's our other special case. Okay, that's going to be that vertical line with an undefined slope. But let's prove it algebraically. Change in y, 7 minus 2. And change in x, 6 minus 6. So our slope is 7 minus 2 is 5. 6 minus 6 is 0. We can't divide by 0, so our slope is undefined. And so for my kids who can't read, cursive, there it is in print, undefined. So that's at vertical line. And then here, when we have a slope that's 0, it's perfectly flat. That's our horizontal line. Okay. Below is a ramp for people with physical disabilities. The measurements are given in inches. The slope for any ramp has to be within a certain standard in order to pass inspection. Okay, it can't be too steep. People need to be able to use their arm strength to be able to get the wheelchair up or down the ramp safely. Any ramp for people with physical disabilities needs to have a slope of at most 0.10. Okay, so at most, that's the steepest that it can be. It can be more gradual, but at the steepest, it can't have a ratio of more than 0.1. Okay, so that basically means for every 10 feet in run, it can't be more than 1 foot tall. Otherwise, it's too steep. It's not safe. Determine if this ramp would pass inspection, and determine if this ramp would pass inspection and justify mathematically your answer. Okay, we got that in there twice. So we look at this and we see 40 over 80. So hopefully when you see 40 over 80, you look at that and you see a 1 to 2 ratio. Okay, so when you see that 1 to 2 ratio, our rise is 1 to 2, that's 1/2. You know mathematically that's 0.5. Okay, that's way too steep. That's 5 times as steep as it's allowed to be. Okay, so this ramp is not even close. It's much too steep and would not pass inspection. Okay, would it pass in a pinch for an emergency, getting somebody from one point to one? Yeah, but it's not something that we need, that's not safe on a regular basis. So this ramp is too steep and would not pass inspection. Its slope is 0.5, and 0.5 is greater than 0.1. Okay, so it does not pass inspection. So this is the limit, and the actual is greater than the limit. Okay, so the actual slope is greater than the limit, so much too steep. Okay, 5 times too steep. Stairs must also have certain measurements to pass inspection. Explain how you would change each step in a set of stairs to make them steeper or shallower. So to make it more steep or less steep, answer both questions. So if you wanted to make it steeper, what would you do? So to make a staircase steeper, okay, so you could put fewer steps, right? And it would be like coming up faster, okay? If you added more steps, the steps with the same rise, you could make it more gradual, okay? So to make a staircase steeper, you could, so if you're making it steeper, you're taking away steps, you're gonna make the run shorter, so decrease the run. And keep the rise the same. So the overall rise, not the rise of each individual step. And then to make a staircase less steep, you could increase the run, so make it longer of a run with the same rise. So increase the run and keep the rise the same. Okay, and then we have tonight some practice problems for you to calculate and interpret the rate of change. So find the slope of each line. Okay, so multiple examples here. Do slope practice day 1 and slope practice day 2. All right, and then when we have our next class, we will take the mini quiz together on slope.